Hi everybody, welcome to factoring expressions with more negative terms. It says factor each expression below as much as possible. Be careful to check for negative signs and double check your work. I'm going to start with number 4 because it's really easy. When we've been factoring, we've been doing something like this. So we'll put a term on the outside here and then a couple terms on the inside. Use, kind of reverse claw. But with this one, you don't have to do that because you've got 10r and 12r. A situation like this, I just add them together, it means I have 22r. So I don't even have to worry about that. Just get rid of it. So there are some examples like that. 5p plus 30, that one I can do with my reverse distributive property, my reverse claw. I can divide both of these terms by 5. So 5p divided by 5 divided by 5 is 1, so I'm left with 1p, or just p. 30 divided by 5 is 6. And if I wanted to double check my work, I do 5 times p, that's 5p, plus 5 times 6, that's 30. So I'm right. I did it right. But number 2 is new to us. Now, what I would do with this one, since it's a subtraction problem, and the variable is negative, I would rewrite this as negative 7n, that stays the same, but instead of minus 70, I would do plus negative 70. And here's why. When I go to factor these, I want to make n positive. I don't have to, but I'd like to make n positive. So what I'm going to do is I'm going to factor out a negative 7. Negative 7. So negative 7n divided by negative 7, well, a negative divided by a negative is a positive. So what I'll be left with is just 1, positive 1, or just n, 1n. Negative 70 divided by 7, negative 7, negative divided by negative is a positive. So 70 divided by 7, that's 10. So I would have negative 7 times the sum of n plus 10. And I can check my work using the distributive property again. Negative 7 times 1n, that's negative 7n. Negative 7 times positive 10 would be negative 70. So right now this is negative 7n plus negative 70, which is the same as what I got here, negative 7n minus 70. Alright, so I paused my recording here and I moved on. I'm going to do number 6. Because we have different terms here. We've got 12 times w, we've got 8, so there's no variable, and we have 4t times w. If we're going to factor anything out of this expression, every term has to share that factor. So I can't factor out w because not every term has a w. I can't factor out t because not every term is multiplied by t. So all I can really factor out is 4. I can see that 4 divides evenly into all of these. So 4, my w stays the same. 12 divided by 4 is 3. 8 divided by 4 is 2. And 4tw, 4 divided by 4 is 1. And the variables stay the same. And I can check again. 4 times 3, that's 12. 12w plus 4 times 2, that's 8. And 4 times 1tw, 4 times 1 is 4, tw. So I'm back where I started. Check my work. Now the last one I wanted to go over with you, you're going to be doing the whole worksheet, but the last one I wanted to go over with you is this one on the back. So we're looking for equivalent expressions. So let's see, 2 times 2x, I know that's 4x using my claw. 2 times 1, that's 2. So what I'm looking at here is 4x plus 2. So obviously this one I'd fill in, yes. But now I've got different expressions. So I've got to figure out which is which. And I don't think we've gone over it in too much detail, but 4x plus 2 is the same. It'll have the same value as 2 plus 4x. I just flip the order. You can do that. So that'll help you here. Good luck, and be good.